All right, welcome to the Explainer. Now, self-driving cars are already out there, cruising through cities like San Francisco and Phoenix, and honestly, they're incredibly impressive. But here's the thing, taking them from just a few cities to every city, that's a massive, massive challenge. Today, we're going to dive into some brand new research from Waymo that suggests a totally different way to teach cars not just to drive, but to actually think.
So here's the plan. First, we'll get into the real problem that's holding self-driving cars back. Then, we'll look at a new flavor of AI, meet Waymo's model, Emma, and see how they get it to explain its own thinking. We'll also see how it's tested safely in a virtual world, all of which points to a whole new future for driving. Let's jump in.
Okay, so what is the single biggest hurdle for self-driving tech today? It's not about driving perfectly when everything's normal. Nope. It's about handling the absolute chaos of the real world.
I mean, think about this for a second. The light is red. That's a simple rule, right? Red means stop. But then a traffic cop is standing there, waving you on. That's a human giving you the exact opposite command. It's messy, it's nuanced, and it goes way beyond just following code. So how does a car make the right call?
Well, today's best systems work kind of like a factory assembly line. You've got these different specialist models. First up is perception. Its whole job is to see the world. Next, the prediction model tries to guess what every car, person, and bicycle is going to do next. And finally, the planning model takes all that info and decides what the car should do. It's a really solid system, but that complexity, that's where the problem starts.
And that system hits a wall that engineers call long-tail events. These are all the strange, unpredictable one-in-a-million things that happen on the road. You know, a mattress falling off a truck, a surprise street festival, or that traffic cop we talked about. For you or me, they're super rare. But for a fleet of thousands of cars driving millions of miles every single day, these things are happening constantly. And you just can't write a rule for everything. So to get around that long-tail problem, you might need a totally different kind of intelligence. Something that's less like a team of specialists and more like one really smart generalist.
Okay, take a look at this situation. It's not just about seeing scooter and person. The context is everything. It's dark. The road is slick and wet, which probably explains why the rider just slipped and fell. This is a super serious high-stakes moment. A traditional system might see the parts, but struggle to put the whole story together.
But watch what happens when you show the exact same scene to a big generalist AI model like Google's Gemini. It's different. It doesn't just spit out a list of objects. It tells a story. It understands the situation. It sees the fall, connects it to the wet road, and immediately flags it as a safety-critical event. That's a whole other level of understanding.
And this leads to a really interesting question. What if you could build a self-driving car around that kind of big-picture thinking? Well, that's exactly what Waymo is exploring with this new research model they've named Emma.
The first version of Emma is so elegant and simple. It just takes two things. First, the live video from all the car's cameras. And second, a simple text instruction for the route, like turn left up ahead. That's it. It feeds both into one single generalist AI model, and that model spits out the entire driving plan. No complicated pipeline, no team of specialists, just one model figuring it all out.
And this whole approach is built from the ground up to scale. You know, the classic systems need all these specialized models and those super detailed HD maps for every single city. Emma uses just one general model, and get this, it can drive without those HD maps. It's designed from the very beginning to crack that scaling problem.
Okay, so this is obviously powerful stuff. But let's be real. The idea of one giant AI brain driving your car can sound a little unnerving. If it's just this big black box, how do we know why it's doing what it's doing? How can we ever trust it?
This is where things get really clever. The researchers use this technique called chain-of-thought reasoning. Basically, instead of just asking Emma for the final answer, they ask it to show its work. It's like, okay, first, tell me the most important things you see on the road. Next, explain what you think they're about to do. Then, tell me your overall game plan, like, I'm going to yield or everything looks normal. And only then does it give the final driving plan. It forces the AI to think things through step by step.
And here's the kicker. That reasoning, that whole process of showing its work, it's not just for our peace of mind. It actually makes the model a better driver, a much better driver. When they tested it on a huge Waymo dataset, Emma, using this chain of thought technique, blew away even the super specialized expert models. It turns out, forcing the AI to reason leads to better results. Who knew? So we have a powerful model, and it's an explainable model. But there's still one more massive piece to this puzzle. How in the world do you test this thing and prove that it's actually safe?
I mean, you can't just put an experimental model on real streets and cross your fingers. And you definitely can't just wait around for millions of those rare, dangerous long-tail events to happen so you can collect data. It's a huge problem for validating any self-driving system. So, what do you do?
The answer is just as futuristic as the car itself. You get another AI to help out. It's wild. Researchers are now using these powerful generative AI models to create endless, super realistic, and totally controllable video simulations. It's basically a custom-built, hyper-realistic video game for the driving AI to play over and over and over again.
And the power of this AI testing AI setup is just incredible. You can change the weather from a sunny day to a torrential downpour with a click. You can go from noon to midnight instantly. And most importantly, you can safely create those super dangerous long-tail scenarios whenever you want, and then replay them thousands of times to measure the AI's performance with total precision. It is the ultimate digital driving test.
All right, let's tie all of this together and see what this research really suggests about the future of cars and the road ahead.
What this is all pointing to isn't just a slightly better self-driving car, it's a whole new playbook. This combination, a generalist AI that gets the nuance, an explainable reasoning process for trust and safety, and generative AI for testing, this is a potential roadmap for finally cracking that global scaling problem.
And that leaves us with a really fascinating thought to end on. For decades, we've thought about self-driving as a robotics problem, a challenge of sensors and mechanics. But this research suggests the future might not belong to an expert in robotics, but to an expert in reasoning. It completely reframes the challenge. And it makes you wonder, what else could we solve not with better parts, but with better thinking?